What is ethanol? Ethanol is a form of energy that is derived from corn. Ethanol is essentially alcohol, but not the stuff you drink. So how exactly is ethanol made? Recently constructed ethanol plants use a dry milling process that begins with grinding the corn's kernels into flour or meal, and the slurring with the water to form a mash. The high-temperature cooker controls the mash's bacteria. Once the mash is cooled, yeast is added to begin the fermentation process that converts the sugar into ethanol, a conventional distilling process that concentrates the ethanol to 190 proof. The process is about the same as that for making moonshine, but ethanol distillers add 5% gasoline to render it undrinkable and to avoid beverage alcohol taxes. The main problem with ethanol production is that it isn't energy effective to produce. Ethanol contains less energy than required to produce it. It takes more energy in the form of fossil fuels to make ethanol than we get out of it. In addition, every gallon of ethanol takes 4 gallons of water to produce. The Granite Fall ethanol plant in Minnesota needs almost 400 gallons of water per minute. That comes out to 160 million gallons of water annually. One of the major problems with ethanol plants is that they consume immense amounts of water that could otherwise be used for agricultural production. With the United States already being strapped for water, you can see how water consumption for ethanol is becoming an increasing problem. This is especially relevant in states like Minnesota that are also huge corn-producing states.
What is a server farm? A server farm or server cluster is a collection of computer servers usually maintained by an enterprise to accomplish server needs far beyond the capability of one machine. Server farms often have backup servers, which can take over the function of primary servers in the event of a primary server failure. How do server farms work? Electricity is produced by alternating a current AC generator driven by steam turbines. Coal is burned to produce heat to boil the water to produce steam. Under high pressure, spins a turbine. The turbine then spins the AC generator, which creates a high electrical current. Hydroelectricity is then generated by moving water through the turbines as it continues on to cool the servers. How much water or energy is being wasted? Water has extraordinary heat-absorbing capability, which in turn makes water very valuable to large internet sources like Google, Microsoft, and Yahoo. Unfortunately, Google's public relations representative wouldn't disclose the specific amount of water that they use at their facility. One server farm, however, provided us with a figure of 13.5 million gallons per day to cool 4 immense chillers. That's 4,536 million gallons of water a year. It takes an average of 0.5 to 0.7 gallons of water per kilowatt of electricity for a coal-fired power plant. Typically, a 1,000 megawatt plant consumes 10,000 gallons of water a minute through evaporation.
After agriculture, the energy industry is the second largest user of water in the United States. Nuclear and fossil fuel production of energy require approximately 140,000 billion gallons per day of fresh water. The water industry itself uses approximately 75 billion kilowatts of electricity per year. To produce this energy requires even more water. The Department of Energy predicts the country will grow by 70 million people in the next 25 years, and the demand for energy will increase by 53%. However, we are already seeing denials for new power plant construction due to water shortage concerns. The IPCC, a group of 2,500 of the most respected scientists worldwide, declared for the first time that global warming is unequivocal and that there is more than a 90% chance that the Earth's warming is caused mainly by the release of CO2. In California, we could be affected by this due to decreased snowpacks in the Sierras, whose snowmelt supplies 40% of California's water. The California Energy Commission has concluded that 44 million acre-feet of water that California annually uses results indirectly in the emission of 44 million tons of CO2. The bottom line is we are seeing higher CO2 emissions and higher water consumption.
In Chapter 4, Glennon talks about how we are fouling our own nest. In the top diagram, we have a sewer system that incorporates both sewage and storm waters. This becomes a problem during heavy rains because it will cause an overflow within the system. and the overflow would carry fecal matter and high levels of nitrate straight into our rivers. Fecal matter carries the bacteria E. coli, and it is extremely dangerous to humans if ingested. High levels of nitrate are harmful to young children, causing a condition called blue baby syndrome, where their blood oxygen level drops to dangerous levels. This poses great health concerns for downstream cities. The bottom diagram shows the Colorado River. The red arrow points in the direction the river flows. Many cities rely on this river, but unfortunately the contaminated river gets worse and worse as it goes downstream. The EPA estimates that more than 860 billion gallons of sewage are annually dumped into America's lakes and rivers. Our own biological waste isn't the only contaminants getting into the water. Agricultural chemicals like fertilizers, pesticides, and herbicides leach and flow into our aquifers, rivers as well. If that isn't bad enough, waste and pollution in the water causes a condition called hypoxia. This happens when there is a high concentration of nitrate and phosphorus within the water, causing algae blooms. When these algae die in large numbers, they suck away all the oxygen within that body of water, creating dead zones where no marine organisms can exist, and ecosystems are destroyed.
Farms and large-scale animal facilities cause a huge problem for our groundwater supply. Dairies and places like football field-sized chicken farms create a huge amount of manure by housing such large numbers of animals for such long periods of time to fatten them up. Each dairy cow, for example, produces 120 pounds of manure a day, and California's Central Valley alone is home to 1.4 million cows. All of this manure is then moved to storage facilities, but because of storms and leaching, a good chunk of the 75% of the 25 million pounds of antibiotics the animals are fed ends up in our water supply. Because of this problem, Tyson, the huge chicken company, created a fertilizer made of their manure and wood chips. You would think that might help, but then because of these same rainstorms, water goes over the fields, taking phosphorus and other pollutants with it, also polluting the water supply. Phosphorus in water encourages algae blooms, creates a foul smell that affects the taste of water, and threatens fish by reducing the oxygen. VOCs, volatile organic compounds, cause problems for the environment as well. In 2007, VOCs, mostly TCE, were found in a majority of wells tested. TCE is linked to immune and brain disorders as well as cancers. It travels downward through the ground since it is so dense and contaminates the water supply. There are two techniques used to rid the water of TCE. The first being to pump the contaminated groundwater to the surface, where exposing it to air converts the TCE to a harmless gas. The second method is to use a special carbon filter on the groundwater. Both of these methods are extremely expensive and don't fully get rid of the problem. Groundwater pollution leads to million-dollar settlements from environmental issues, as well as millions of dollars spent to actually fix the problem. Finally, surprisingly, the FDA does not require bottled water companies to treat their products to remove a variety of pesticides, heavy metals, and bacteria.
This is the proposed MTBE movement in the environment. Methyl tertiary butyl ether, treated gasoline, has leached into aquifers and has spawned hundreds of lawsuits around the U.S. Environmentally, these spills are worse than regular gasoline spills due to its water solubility and its capability to travel faster and further than gasoline, and it does not biodegrade. Also seen here are perchlorate. An estimated 50 pounds of perchlorate per day enter the Colorado River. A 2007 study done by the U.S. Accountability Office found about 200 sites in California and Texas where perchlorate has contaminated drinking water, groundwater, sediment, or soil.